Let's get started. Standard form and significant figures. So the first thing that we're going to do is expressing numbers in standard form, and also being able to count a number of significant figures in any number that is given. Now, when we are talking about standard form or scientific notation, this is just the form that we use when you have got very small numbers or very big numbers. In science, you are going to be working with very small numbers or very small volumes. So for you to make sure that you get to express them in the right unit that is easily understandable, you need to make sure that you understand standard form and also significant figures. Now, when you have got a number such as 82 million, this number might be too big and you can't continue. Imagine you're multiplying this number by 1000. You can't be writing everything. So that is why it is very important for you to get to write it in standard form or the scientific notation. So when you're writing in scientific notation, make sure that whenever you've got a whole number like this one, this means the decimal point is at the very end of the last number that you are able to see. So the last number that you can be able to see here is a zero. So meaning the decimal point is here. That's the meaning, even if you can't see it. So you need to make sure that you move the decimal point nearest in or behind a whole number, not a zero, behind a whole number, that is 1 up to 9. So let's move this point. That will go 1, 2, 3, 4, 5, 6, 7. So it has moved 7 times. Therefore this number can also be written as 8.2, and then you say times 10 to the power. We moved it 7 times, but because we're going to the left, the power is going to be positive 7. This is in standard form of the scientific notation. So if this was 0.00000000125, you want to write this in standard form. In this case, the decimal point is at this point, we can see. So we're going to move, we go in a direction such that the first one number we're going to find is going to have the decimal point on its right. Please, not the first two numbers, only the first number. So this decimal point will move from here: 1, 2, 3, 4, 5, 6, 7, 8. Please don't take it here or there. It has just moved 8 times. So therefore this is going to be written as 1.25 times 10 to the power. Because we are going in this direction, we are going to the right, the power is going to be negative 8. Whenever you go in this direction, put a negative on the power. When you go in this direction, put just it's a positive, and you don't put a positive anyway, so it is going to be positive. So this is how we get to write in standard form or scientific notation. Is it okay? Is there anything that has a question on this point? Anything that has got a question? Okay. Now another thing that you need to understand is some measurements. There are some values that you need to take note of what they mean. Now before knowing those, we need to understand significant figures. We need to know that the first rule of counting significant figures is a whole number from 1 up to 9 is always significant. So in this one, we have got 4 significant figures. Any number between 1 and 9 is always significant. Now for 2, numbers from 1 to 9, if they are followed by zeros, those zeros are not going to be significant. For example, 82000. These three zeros we can see here are not significant because they are on the right of four numbers. So in this number, we have two significant figures. If you have got 81.000, zeros on the right of after a decimal point are always counted as significant. On the right of a decimal point, they're always significant. So in this one, we have got 5 significant figures, but zeros on the left of a number are not significant even after a decimal point. So in this case, these zeros we can see in front, they are not significant. Therefore, we only have three significant figures. Zeros on the right after a decimal point are always significant. So even if we have got 0.00100, these two zeros here, they are on the right of a decimal point. The decimal point is there, they are on the right. Don't count these two. Okay, we say zeros on the right of a decimal point after a number which is significant. So this number is significant, so the zeros that are going to come even after a decimal point, they are also going to be significant, not before a significant number. So therefore this one, there's three significant figures. I hope this is making sense. And zeros between numbers, zeros that are between one numbers are always significant, whether there is the decimal point or not. So here we have got four significant figures. So this is basically on significant figures. Hope we've seen. From here, as simple as it seems, you need to really pay attention. So is there a question here? Is there a question? Yes, please. um okay, all right. So when you have got a whole number and that one number doesn't have a decimal point, the zeros that come after a number between 1 and 9, they are not going to be significant. That's why these are not significant. If you go to the fourth point, any number, any zero that is in front, whether there's a decimal point or not, as long as they're in front of a whole number, this is a number between 1 and 9, they are not going to be significant. That is why these are not significant. And then zeros that are on the right of a whole number, that is a number between 1 and 9, after there is a decimal, then those zeros are going to be significant. So for this one, they are not significant. Why? Because there is no decimal. So if there was a decimal point here, if it was 0.82 and then 000, these would have been five significant figures. Why? Because these zeros are after a whole number and then there is a decimal in front. And again, just this very same number you can see here, if it was 82,000 and then I put a decimal point here, then this number has got five significant figures. Why? There is a decimal point here. But this one has got two significant figures. Why? There is no decimal point. That is why you need to pay attention to where the decimal point is. So as long as there is a decimal point, any zero that is going to come after a whole number is always going to be significant. But if there is no decimal point, the zeros that come after a whole number, they are not significant. Is it cool? Alright. Now after understanding standard form and significant figures, we are going to look at the rules of rounding off and also prefixes. These are very, very important. Rules of rounding off, prefixes, and the rules of addition and multiplication. Okay, so I'll first start with the rules of addition and subtraction. Imagine you have got these numbers, you've got 1.25 and then plus 1.001 and then plus 1.2. You want to add these. How are you going to give your answer? What will be the answer? So when you want to add these numbers, I can also write this as 1.25 and then 1.001 and then 1.2. So let's add them. So just to make sure that the decimal points are going to be together, I'm going to put a 0 here, I'm going to put a 0 here and a 0 here. Remember, those zeros are not there. So 0 plus 1 plus 0, that is going to be a 1. 2 plus 5 plus 0, that is going to be a 5. I mean 5 plus 0 plus 0. And then 2 plus 0 plus 2, that is going to be a 4. Then we've got a decimal point. 1 plus 1 plus 1, that is a 3. So this is the value, 3.451. So I'm going to put it. This is going to give us 3.451. But this is not the answer. If you are doing chemistry and you write this value, they can remove some marks. So you are going to look at which one has got the lowest number of decimal places. Decimal places. So whenever there is addition and subtraction, look at the smallest number of decimal places. This one has got 2 decimal places, this one 3 decimal places, this one has got 1 decimal place. So the smallest, that is 1 decimal place. So the final answer should be written to 1 decimal place. That is going to be 3 point. So now you need to know how to round off. You need to put this one to 1 decimal place, so it should end here. So look at this number, which is, that is a 5. So we're going to remove 1 from that 5, we put 1 there, 4. That would be 3.5. So this is the answer. If you write this one, that is going to be wrong. So you look at the number with the lowest number of decimal places and make sure that the final answer that you get, round it off to the lowest number of decimal places. Is it okay, or there is a question? Is there a question or not? All right. So when it comes to multiplication and division, you look at, so here we are saying lower decimal place, but for multiplication and division, you look at lower significant figure. Let's say we are multiplying 1.01 times 2.3. Let's say 0, 0. Let's get to multiply this and we see the final answer that we are going to get. I can as well write this as 1.01 and then multiplied by 2.300. So I'll put a multiplication there. We'll first start with this 0. So when this 0 multiplies 1, that will be, let me just write it well so that I start with the bigger one and then the small one. I'll write it down. This will be 2.300 and then this is multiplying 1.01. So this one multiplying with this 0, that will be a 0. The one multiplying with another 0, that will be 0. 1 multiplied by 3, that is going to be a 3. 1 multiplied by 2, that is going to be a 2. Imagine the decimal place is not there. And then 0 multiplies with these numbers, those are all going to be 0. So where there is 0, so I'm going to move, instead of me putting the first value here, I'm going to put it here. Just the same of being multiplying. So this is going to be 0 times 0, 0, 0 times 0, 0, 0 times 3, 0, 0 times 2, 0. And then we'll multiply 1 times 0. So again we'll change, we'll put here. That will be 0, 1 times 0, 0, 1 times 3, 3, and then 1 times 2, that's a 2. Now we're going to add this. So this is going to be 0, 0, 3, 2, 3, 2. Like that. So if we see what we are multiplying this one at, how many decimal places are here? These are 3 decimal places, and then these are 2 decimal places. So together they are 5 decimal places. So the final answer is going to have final 5 decimal places. So this is going to be 1, 2, 3, 4, 5. So that is going to be 2 point, like that. So this is 2.32300. That is the answer. Now, are you going to present the answer like that? No. you need to look at which one of these two values are the lowest significant figures. So this one has got 1, 2, 3 significant figures. What of this number? How many significant figures are there? So we can see that this is 1, 2, 3, 4. These zeros after a whole number which has got a decimal places, with a decimal place, they are significant. So we have got 4 significant figures in 1 and then 3 significant figures in 1. So the final answer is going to be written to 3 significant figures. Therefore this value is going to be written as 2.32. These are 3 significant figures, just the first 3. We can't remove a 1 from here because it is below what? It's below 5. Are we clear with that? Are we clear with that, or there is a question somewhere? And these you need to pay attention because as simple as they seem, actually these are the things which many people lose marks on. Is it okay? I'll ask for the last time. Okay, we take it that it's fine. Now let's look at the rules of rounding off. Rules of rounding off. The first one, when you are rounding off from any one number that is below 5, you don't remove any number. For example, 2.453200. You want to write this number to 3 significant figures. This is going to be equal to 3 significant figures, means count from here 1, 2, 3. So we want only these first 3. So you look at the number that comes after the last number you're talking about. So this is the number that comes after the last number we're talking about. That number is below what? Is below 5. So therefore this one to 3 significant figures is going to be 2.45. So that's the rule. Another one, anything as long as the number that comes after the number of interest is above 5, you are going to remove a 1. For example, 3.45611. We want to write it to 2 decimal places. What does 2 decimal places mean? Look at where the decimal is and then 2, 1, 2. So we look at the number that comes after. This is a 6. So we're going to remove the 1 from the 6. We're going to put on the 5. So that is going to be 2.46. And then after this, now we come to the tricky part. When you want to remove a number from 5, that is the trickiest part. So these, oh, I know we've been doing them from secondary school. Now, when you have got 2.5, let me first say 2.45. You want to write this number to 2 significant figures. How are you going to write it? So 2 significant figures means 1, 2. You look at the number that comes after. This is a 5. So if the number that you're supposed to remove from is a 5, you are supposed to check, are there numbers after 5? So you look at numbers this side. So if there are numbers which are this side, are either zeros or there is nothing. For you to be able to round off, look at this number which is here. If it is odd or even, that is what is going to determine what you are going to do. So if it is even, don't remove anything. So in this case, is this an even number or an odd number? Let me see. Who can tell us? Is it an even number or an odd number? Anyone who can help us with that? No one? We've forgotten. Is 4 odd or even? Yes, 4 is an even number. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, like that. Those are even numbers. So since this is an even number, we will not remove anything from 5. So therefore, to round out these to two significant figures, this is just going to be 2.4. That's it. That's how you round it off. And same when we had, let's say, 7.8500. We want to round off this to, let's say, one decimal place. One decimal place. Look at where the decimal place is. So we just want to have one number here. Look at the number that comes after. This is a 5. So we need to look at the numbers that follow 5. If there is nothing or there are zeros, then you need to look at this number which is here. Is it odd or even? This 8 is even. So this one is going to be written as 7.8. You don't remove anything from 5 because it is even. So now let's say this number was 8 point, let's say 8.3500. Want to write these to two significant figures. This is going to be two significant figures. We want this and this. So look at this. We have got a 5 and then it is followed by zeros. Whether it is followed by zeros or nothing, you need always to look at this number which is here. That is a 3 and 3 is even. Therefore, this is going to be, 3 is odd. This is going to be 8.4. You are going to remove a 1 from a 5 and then put on the 3. That is a row. Or even if there was nothing this side, for example, when you are talking about 6 point, let's say, 995, you want this to be written to three significant figures. Three significant figures, that is 1, 2, 3, is followed by a 5 and there's nothing this side, so we need to remove a 1 from this. Why? We look at this one, it is odd. So if we remove a 1 from 5, we're going to put on 9. 9 is going to become what? 9 is going to become 10. And we can't write 10. So from that 10, we still remove a 1 we put on this one, it becomes also 10. We can't write a 10. From that 10, we still remove the 1 we put on this one, it becomes a 7. So this is going to be 7.00. This is three significant figures. It is very different from 700. This is only one significant figure. 7.00 is three significant figures. Now, when you're rounding off, but the number that comes after a 5 is not a 0, for example, 7.43500, and you want to write this number to three significant figures, look at this. 1, 2, 3. A 5 is the number that comes after, but these numbers which are here, there is another 0. So the rule of looking at even and odd is not going to apply for this case. Therefore, this number is just remove a 1 here and put on this one. Okay, so we're going to remove a 1 and put going to be 7.44. That is how you're going to become. So as long as there's a 0, just remove a 1 from 5 and then add to the previous one. So this is the rule of rounding off. Let's hope they are fine. Are we? Are we okay? Are we good? Or there are some questions? Now, apart from this, let's look at prefixes, and we need to know prefixes. I'm going to start with here 1. I'll just write a 1 here. So on top, I'll be going with numbers which are above 1. I'll be moving in multiples of 3. But first I'll write with a multiple of 1 and a multiple of 2. And then I'll start moving in threes. So the first one I'm going to write is 10 to the power 1. And then 10 to the power 2. And then we have got 10 to the power 3. Now I'll not have enough space. Let me reduce my handwriting. So to the power 1, 10 to the power 2, 10 to the power 3, and then from power 3 we'll go to the power 6. From power 6 we'll go to the power 9. Power 9 will go to the power 12. I'll just end at 12. And then also down we'll 10 to the power negative 1, and then 10 to the power negative 2, and then 10 to the power negative 3, 10 to the power negative 6, 10 to the power negative 9, and then to the power negative 12. So when you are anything 10 to the power 1, these are positives. The prefix which follows such, let me first go to the negatives. 10 to the power negative 1, the prefix that follows that, this is called a this is where you find decimeter, deciliter, something like that. And then 10 to the power negative 2, this is a, that is why we hear of a centimeter, cent what. 10 to the power negative 3, this is e. So that is where we get a milliliter, milligram, 10 to the power negative 6, that is a mic. And then 10 to the power negative 9, this is called nano. 10 to the power negative 12, this is called a pico. So these ones we need to know them. Now they are symbols. A dec, we just use a cent, we use small c. A milli, we use small m. A micro, we use mu. And then nano, we use small n. Pico, we use small p. So these we need to have them. And then as we get to go up, we have got 10 to the power positive 1. This is called 10 to the power 2. This is called hectometer. 10 to the power 3. This is called, this is a mega. 10 to the power 6. This is 10 to the power 9. That is a tera. Okay. Actually, I've left out something here instead of me putting it away. I've left out 10 to the power 3. 10 to the power 3 is called a kilo. That is where a kilometer comes from. And then 10 to the power 6, this is now mega, means a million. And then 10 to the power negative 9, I mean positive 9, this is, and then 10 to the power 12, that is now a tera. Okay, that's it. Now deca, top we use capital. Since the small, the ones which are down with negative powers, we use the small letter. Hecto, we're going to use h. Kilo, we use k. And then mega, we use capital M. Giga, we use capital G. Tera, we use capital T. These ones we need to be very familiar with them because they're very important. For example, let's say you have got 20,000 meters. They ask you to this one. They ask you to convert this one to meters. How can you convert 20,000 meters to gigameters? So what we are going to do is we'll just get this 20,000 meters. I'm going to multiply. Write this dash like this. So I've got a meter on top. I'm going to put a meter down because I don't want to have a meter. What I want to have by the end of the day is a gigameter. So I'm going to put now gigameter here. Now whatsoever, where we put whatsoever unit we are talking about, well, if it is a meter, if it's a gram, if it is maybe, I don't know what unit you are talking about, without these prefixes, without gigameter, terameter, just that very unit you are talking about is here. In this case it's a meter we are talking about. So we can see that giga is on top, so a giga is bigger than a meter. So we are going to, on the bigger unit I'm going to put a 1. So in 1 gigameter, how many meters are there? And then we'll go where there is giga here. So in 1 gigameter we have got 10 to the power 9 meters. Therefore this meter and this meter is going to cancel out. I can also write this one in standard form. 20,000, the decimal point is here, so I can move 1, 2, 3, 4. It can move 4 times. So this is the same 2 times 10 to the power 4. So this is become, we have got 2 times 10 to the power 4. This is going to multiply with the one which is on top because they're both on top. And then in the denominator, we're going to have 10 to the power 9. And then the unit here that has remained is what? Is the gigameter. So this is going to be the answer. All we do is simplify. We know from that same basis dividing, we subtract the powers. So this is the times 10. So subtract the power starting with the one on top. So that before minus 9, that is going to be negative 5 gigameters. So this is going to be the answer. 2 times 10 to the power negative 5 gigameters is equal to 20,000 meters. So if you are talking of, let's say, let me some